Okay, guys, what's going on? We're going now to, instead of going from moles to moles, we're going to go from moles to mass. All right, so we're going to start here. Same thing, all stoichiometry problems, we need a balanced equation. So we need to balance this guy real quick. Zoom in a little bit. Okay, we have AL. We have CL. There are two of them. There are one of these guys. One AL over here, and 3 chlorine over here. Currently, aluminum is balanced. We need to make sure, all right, the chlorines they can't do this right here. So closest dude that they can wind up sharing is a 6. So if I make this a 3, it's going to give me 6. If I make this a 2, that gives me a 6. So they would be balanced. But what I multiply by becomes the coefficient. And now that has to occur, the coefficient applies to the entire compound. So this aluminum also has to get doubled. And then that means that this aluminum as well has to get doubled to balance out. So now we have 2 aluminum, and 6 and 6. We're good. We're balanced. So 2 moles of aluminum will react with how many moles of Cl2? 3. And that's going to produce 2 moles of aluminum chloride. Now, B, how many grams of AlCl3 will be produced if 2.5 moles of aluminum react? So, same kind of thing. Underline what you're given. That's A. Underline what we're looking for. Grams. That's B. So from here, we're going to look at our mole map. Okay, we want to get to grams of B, which would be this over here. Where are we starting at? Moles of A. So we got to go from here to here to here. So these are going to be our 2, conversions. The first one is, to get out of moles of A and get to moles of B. So take what you're given, put it in the starting spot. Okay, so this is where we are currently here. All right, to get from moles of A to moles of B, which is the first thing, you have to use this guy here. Okay, so we want to go to B, AlCl3. So with that, we need to know what the moles of B are. In this case, it is 2. Where does this come from? All right, balanced equation. And moles of aluminum on bottom. All right, to go from one unit to the next, whatever unit you have on top, you got to have then on bottom in the next conversion for them to cancel out. Okay. So we would be left currently, if we stopped right here, with moles of aluminum chloride. But we have to get over here. So in which case, we need to have, all right, because we want grams of AlCl3, that needs to be on top in the conversion. Grams, AlCl3. And on bottom, we need to have moles. Now, what do we have to do here? We're going to use 1 mole. So if we were starting with 1 mole of A, we would cover up everything else right now because we don't need it. Okay, moles of B on top, moles of A on bottom. A's would cancel, moles there. 1 mole is going to go underneath here because we're going to figure out how much mass, the molar mass of aluminum chloride, the AlCl3, in just 1 mole of that. So 1 mole goes down here. So they would wind up canceling. Moles would cancel. So where does this number come from? The molar mass from the periodic table. Okay. So I'm just going to do this over here real quick. AlCl3. Aluminum is 26 points. Where's my periodic table? Look up aluminum, 26.98 grams. Plus, what is chlorine? I know that one, 35.45. But how many chlorine do we have? We have 3, so I'm going to multiply that by 3. I'm going to throw this into the calculator real quick. 35.45 times 3, and then add 26.98 and 133.33. That is grams of Al, all right, or grams per mole of aluminum chloride. So that number, that 133.33, will go there. And moles of AlCl3 cancel. We're going to be left in the unit that we wanted, grams of aluminum chloride, the AlCl3. And same thing, but like before, we multiply everything on top, divide by what's on bottom. So we're going to take our 2.5 times 2 times 133.33. Okay, and then divide that by 2, because that was what was on bottom. And we should get an answer of 333.325. And the unit, well, the only one that wasn't canceled out, grams. Bam. Okay, so that is an example of going from grams to moles. What happens, though, when we have to go from, this was happening when we went from moles to grams. Now we're going to go from grams to moles. So to do that, let's underline what we're given with. That is our A. What do we want? Moles of Cl2, that's B. All right. So where we're starting here, we're starting in mass of A. We want moles of B. So our conversion here is going to be 1 mole of A over its molar mass, and then right here, our mole ratio from a balanced equation. So take what we're given, put it in the starting spot. 12.3 grams of AlCl3. Okay. So that is here. Now, to go from here to here, we're going to need to have 1 mole of A on top and in the molar mass on bottom. So we're going to write 1 mole of aluminum chloride, all right, because we need to get out of this now. That means grams, since grams on top, we have to have grams on bottom. But where the heck does this number come from? Again, that is going to come from the molar mass of the element or compound from the periodic table. Now, since we already found that molar mass from the previous problem, all right, from letter B, we get to use that again, which is nice. So grams would cancel. And now we would be here, but we need to get to B, moles of B. So we got to use this guy. So we need to have moles of A on bottom, blank, moles of AlCl3 on bottom. And what do we want? Moles of Cl2 on top. Where do these numbers come from? These guys here. They come from our balanced chemical equation. So if we look up top, okay, the coefficient for chlorine was 3. So that is what we're going to have here. And the coefficient in front of the aluminum chloride is 2. So that is what we're going to have here. And moles on top here of AlCl3 and moles on bottom, they will wind up canceling, giving us the right unit that we wanted, moles of chlorine. So same thing as before, multiply everything on top, divide by everything on bottom. So we're doing 12.3 times 3, awesome, divided by 133.33, and then divide that by 2. And we're looking at 0.1383. I'm just going to call it 0.138. And the unit would be moles of Cl2. D, how many grams of aluminum do we, that's what we want. That's going to be B. What are we given? 3.4 moles of chlorine. That's A. What the heck is chlorine again? Well, that's the Cl2. And aluminum is just the Al from the problem. So I'm going to take what I'm given, put it in the starting spot. 3.4 moles of chlorine. So I'm given moles, and I want to get to mass, right? It says grams of aluminum. So that's grams of B, mass of B. So first, going to do this, all right, conversion. So moles of B on top. B was aluminum, so moles of Al on top. We got to get out of moles of A, which was chlorine, Cl2. These numbers that we're going to use here, that comes from our balanced chemical equation. So we look back up at the balanced formula, and it's a 2 and 3. So aluminum is going to be a 2. The chlorine is going to be a 3. So we're out of that. Cool. That would give us, if we stop the problem right there, we would be in moles of B, but we want mass of B. So the next conversion is molar mass over 1 mole of that. So we got to get out of aluminum. We have to get out of aluminum. So in 1 mole of aluminum, what's going to be on top? The molar mass. Now, since this is just an element, it's super, super great and easy. Just look up on the periodic table, 26.98. Grams of aluminum. So since we have moles of aluminum on top and bottom, they cancel out. All the units cancel except for the one that we wanted, and that is grams of aluminum. Same thing as before, multiply what's on top, divide by what's on bottom, and we will come up with an answer of approximately 61.15 grams of aluminum. Okay. All right, so guys, these are going to be the examples that you get to use, all right, to go through and complete this topic here. Shouldn't be any kind of crazy tricks, all right? As long as you get the molar mass correct, then this should be no problem.